Okay, so we're gonna go into DOPS, and what you want to do is type down DOP network. When you type down DOP network, sorry, it's gonna come in empty, nothing in it. So let's come into the one that I created, and I'll show you what you're gonna want to build in here. Let me just delete this because it is distracting. I was using that for tests, and this is the only thing that we're gonna want to use, a flip object. So let's create this from scratch. The first thing that you want to do is drop down a flip object. Flip object. Okay. On the flip object, we want to go and grab our source, the one that we painted red on the outside. So we go here and we go out source and say okay. Boom, it's gonna bring it in. So if I type here, hit here, it's gonna show me, oh, it's grabbing the source. Good, that's what we want. All right, so we got our source, and then we're gonna say particle field, and then we got all this bunch of huge particles. So we want to go to guides, to particles, and we want to tell Houdini to just show us particles instead of all of that. And there we go. Okay, so we got our base particles here, and then we're gonna do flip solver. So right now the flip solver isn't really gonna do anything because we need some kind of force to affect them. So let's drop down a pop force, and let's crank this number up here, and let's hit play. So right now it's not working because we're gonna need a few more particle separation points in here. Usually you want to copy and paste this to points from volume, or when you're using but when I use a scatter, I just kind of like find the sweet spot here. Okay, and you can see that this is now affecting the particles, and this isn't like a regular kind of like flip network where you have like a volume source here and it's like a hose where it's emitting particles every frame. This is just like kind of like using a particle network with liquid physics. So boom, we got it working. But how do we get the effect that I was showing you guys on the tutorial course? What we want to do is drop down a merge first, because we want to bring in our geometry, and we're going to type in static geometry. Okay, we're going to hit this button here for sub path, and we're going to select the collider, and then in our collider we want to say this is deforming and this is an object that I want it to be transformed. So now we have it moving, but on the collider we want to come here onto bullet data and tell it show me the collision guide, and you'll see that this is definitely not gonna work. So we want to turn this to concave, and now we're gonna get proper collisions. But you want to turn off show guides and turn it back to display geometry so it's not too slow. Then you want to connect both of these ones, and you want to make sure that this one is on the left and this one on the right. If they're not, you can switch them here, but it does affect the Houdini if you don't have them in that order. So now let's hit play again, and we can now see that the geometry is being affected by our collisions that we animated earlier, but our geometry is also being animated with this pop force that is affecting everything, and that's not gonna work for us. So what we want to do is we're gonna say pop force, I want you to affect the group, and I want you to affect the active group only. So if we hit play, you'll see that all of the points are now static, but as they begin to get hit, they also become active, and that's where the magic happens. That's where we can really control what areas we're gonna destroy, what areas are gonna get splashes, and what areas are gonna be static. A very, very powerful technique. Okay guys, so I'm gonna delete this because we already have it here, and we are going to come out and cache this. So this time we want this to be time dependent cache, so we're gonna do a file cache, and we want to say time dependent, and I like to tell it to be explicit, $os/$os.$f.bgeo.sc. Creates a folder, puts this thing with this name on the folder, gives it, actually this is not a slash, this is a dot, gives it $f, so whatever $f, whatever frames we're gonna export as a bgeo.sc. And then we are going to look at the particles that I've already got cached, which are the ones from the tutorial. So if we move a couple frames down here, we'll be able to see that I did use quite heavy amount of particles. Let's see. Boom, and then that's an example of what it was looking like. So there's multiple ways of meshing it, and the way that I'm gonna show you guys that I meshed it is VDV from particles. So if you drop down this cool node called VDV from particles, it's gonna basically turn it into particles, VDVs, and what you want to play with is the voxel size. So see that my voxel size is 0015, very, very low value, which makes it very high, very high resolution. So I'm gonna add a VDV smooth after that. So it's something that you guys really want to know, that this value of my VDV from particles of this is not gonna work for you guys, because unless you have the same amount of points, that doesn't work. So you gotta start playing with 0.1, 0.05, 0.02, 0.01 till you find the right number. And then sometimes you might not even want to use a smooth, because smooth just kills a lot of the detail. And then we do a VDV convert, and on the VDV convert, we want to tell it to turn it into polygons. So this is what I rendered out. I can't really play it back and forth because it's going to be really slow. But what I can do is freeze a frame so that we can scrub. So I'm freezing frame 45, and then I'm just going to drop down a material. Connect it here, and I'll show you guys how I went about creating a material. I hope you guys like this tutorial, and I'll be back with more.